Now we begin with the third chapter, which is called as polynomials. Now first let us see what are polynomials. Although you are familiar with this word polynomials in your lower classes, the definition of polynomials goes like this. Why should we know the definition? Because in your first exercise, you have a question to identify polynomials. So, what are polynomials? They are algebraic expressions in which the powers of the variables are whole numbers. So, if the powers of the variables are whole numbers, what can the powers of the variables take the value of? Either they can be positive integers or they can be 0. Now, look here, the example. The first example you have here, x cube plus 2x square plus 5x minus 3. Okay. Now, this is the first example. If you look at the variable here, it is clear to you that the variable used here is x. What are the powers here? The first term, the power is 3, which is a positive power. Here 2, again this is a positive integer. Here, when it is only written as x, means what is the power? It is 1. And if there is no x written there, what does it mean? Here I have only minus 3. Means that it is minus 3 into x raised to 0. Now why am I saying x raised to 0? Because x raised to 0 is 1 and minus 3 into 1 is minus 3. So how are the powers written then? 3, 2, 1, and here it is x raised to 0. So 3, 2, 1 and 0. Going to the next example. You have m square plus half m minus 7. Is this also a polynomial? Yes, it is a polynomial. What have we to look for? Only the powers of the variables. The variable here is m. What is the power? Here it is 2, here it is 1, and here it is 0. So this is a polynomial. We don't have to worry about this half. This half is not the power of the variable. It is just the coefficient of m, that is the number in front of m. Therefore, this will be a polynomial. Next one, y square plus 5. Here the power of the variable is 2. Here the power is 0. 2 and 0 both are acceptable. Therefore, this is a polynomial. See the next one. Here you have m square plus 2n cube minus root 3 m raised to 5. Now here you will see that we have here m square plus 2. We can make this m cube. Okay, m square plus 2m cube minus root 3 m raised to 5. So this polynomial is in m. So if it is in m, m is the variable. What are the powers here? 2, 3 and 5. All of them are positive integers. Therefore, it is a polynomial. What is the coefficient of this m raised to 5? It is minus root 3. But that is only the coefficient. So, still this will be a polynomial. Going further, you have one more polynomial here. Here we have 3m cube n raised to 6 plus 7m square n cube minus mn. Now this polynomial is in two variables, m and n. You can see both m and n here, and because this polynomial is both in m and n, there is nothing wrong here. We have to just see the powers of this polynomial of the variable in the polynomial. In the first one, if you see the powers of m, it is 3, n it is 6. Here m it is 2, n it is 3. Here m it is 1 and n it is 1. Therefore, this will still be a polynomial. What about 6? 6 here is 6 x raised to 0. So the power is 0. So we said that if 0 is there, still it will be a polynomial. So 6 also is a polynomial. Same way when we write half, half x raised to 0. So again the power is 0. So still half will be a polynomial. What about 0? It is 0 x raised to 0. Means 0 into 1, which is still 0. So 0 also will be a polynomial, and same way root 3 also will be a polynomial. Then let us see what are the examples of not a polynomial. Now see here, we have here root 5 plus 8. Now when we say root 5 plus 8, what is the power of y here? It is y raised to half plus 8. When we are saying root 5, it means y raised to half plus 8. What did we say when we defined a polynomial? The power should be either positive integers or 0. Is this a positive integer? No, it is not a positive integer. Therefore, this will not be a polynomial. What about the next one? 3 minus 1 upon y. So, this will be 3 minus, if I take y to the numerator, y now is in the denominator. If I take it up, what happens? It becomes y. Here it is y raised to 1. In the numerator it will be y raised to minus 1. But what should be the power of the variable? It should be a positive integer. So here I have minus 1. So can this be a polynomial? No, it cannot be a polynomial. Next one, this is x raised to root 2. Now, is root 2 a positive integer? This root 2 is not a positive integer. Therefore, x raised to root 2 minus 3x is not a polynomial. Next one, x raised to minus 2 plus 7. When the power of the variable is minus, it cannot be a polynomial. We should have either positive integers or it should be 0. So therefore this also is not a polynomial. So I hope now it is clear how we distinguish a polynomial from an expression which is not a polynomial.